Hello everyone. So today we'll continue with module 1, and today we are going to discuss about performance. Um, so this is the most important thing. So we are measuring the performance of any system we are building. Okay. So we will discuss which are the system attributes that are affecting performance. Okay. Again, the ideal performance of a computer system depends on a perfect match between the machine capability and program behavior. Okay, because on the machine we are running the program, so there are two main system attributes. One is machine, and one more is program behavior. So machine capability can be enhanced with better hardware technology, innovative architectural features, and efficient resource management. Okay, so it can be enhanced with better hardware technology, innovative architectural features, and efficient resource management. Okay, so by doing this we can achieve better performance of the machine. But however, with program behavior, it is difficult to predict due to its heavy dependence on application, which type of application we are running, and also the input, what runtime conditions, like what inputs we are getting at the runtime. So that will affect the program behavior. Okay, so these are the two important system attributes that are affecting the performance. And there are also many other factors affecting program behavior, including algorithm design, data structures, language efficiency, programmer skill, and compiler technology. Again, it depends on the experience of the engineer who are going to develop those systems. For example, in third sem, if you are developing any algorithm, so we will design algorithm in such a way that it may not be efficient, because by experience you will get more knowledge, and you will get to know how to optimize the solution. Okay, and also data structures. If you come to data structures, we have many uh, alternatives. We can use arrays, we can use binary trees, we can use linked lists. And again, it depends on the experience of the programmer, which data structure is suitable for which kind of uh, uh, applications. Again, that also affects your program behavior. So you have to efficiently choose the data structures. And second is language efficiency. For example, suppose if you are running um, Windows operating system, which language, for example, for Windows operating system, we are using .NET applications, because Windows prefer .NET framework, and in .NET again we are using C sharp languages. And if you go to the Macintosh operating system, they are using Objective C language. For iOS, okay, they are using a different kind of language. For if you come to the Android, again Java is used. Again, language efficiency for different platforms, we are using um, different types of languages. Again, it depends on the experience of the programmer. Initially, it will take 2 to 3 years to move from beginner level to the intermediate level. So that's why in market they hire experienced peoples, because experience comes by working more and more on the same things. Okay, so always it is better to choose the language which is most valued in the industry. So you have to survey before. Don't learn any languages just blankly that somebody is telling it, because based on the language you'll get very good opportunities when you join the industries. So it is very important uh, for you to choose which language you want to learn, and which companies are behind those language, whether that going to last for next 20 years or 15 years. Because for learning any language effectively, it will take around 3 years. After 3 years, if you think that that language is not good in the market, then again your value is also underestimated. Again, that will affect your salary, that will affect your mental stress level. Okay, so suppose if your language is booming in the industry, then you will get very good package, very good salary, very good promotions. So always choose languages based on the it is widely used. Okay, make a survey. Okay, for example, we have now C++. In your syllabus you learn all the languages like C++, Java, .NET, but you are not perfect in any one of these languages. You are just introduced to the language, but you cannot build a fully fledged software with those languages within 3 months. It will take some time. Okay. So keep in that mind and choose the languages. And programmer skill also, again it depends on how his learning abilities, and how much hard work he is doing on learning those different language skills. Because again, when you write a program, so these three factors, the algorithm design and data structures, are independent of the language. But language, if you use any language, C++, Java, .NET, Python, anywhere, but here you have to use algorithm and data structures. You should have very good knowledge about algorithms and data structure. If you're strong in this, you can learn language. Language will take some time, but these two are very important because it will decide the efficiency and performance of the system. Okay. And compiler technology, so whatever you write in high language, that has to be converted into the low level. So for that, again, compiler technology also affects the performance. Okay. So one is machine capability and second one is program behavior. And again, in program behavior we have algorithm design and data structures, and we have language efficiency and programmer skills and compiler technology. Okay, these things are going to affect your performance. Okay, as an computer architect, you should know have grip over all these things to build a efficient system. Okay, next, the simplest measure of program performance is turnaround time. So what is turnaround time? Okay, so we are going to measure program performance using turnaround time. And then what is turnaround time? Okay, so turnaround time is nothing but it includes disk and memory access, input and output activities, compilation time, OS overhead, and CPU time. So all these includes turnaround time. Suppose if you want to execute a program and if you want to measure the performance, and you have to find the turnaround time. So turnaround time is nothing but disk and memory accesses, input and output devices, activities, sorry, and compilation time, how much time it is taking to compile, and OS overhead means some other uh, OS activities which are affecting your program, and CPU time, how much time taken by the CPU. Again, we have separate equation for CPU time, and we will solve some problems based on the CPU time. So we will measure the performance based on CPU time also. So basically turnaround times includes all these five factors. So the clock rate and CPI is nothing but clocks per instruction. Okay. So again, clock rate and CPI also affects the performance of the system. Again, if you see, CPU of today's digital computer is driven by a clock with a constant cycle time t. The inverse of cycle time is clock rate, that is nothing but 1 by t, that is frequency is equal to 1 by t. Okay, we use these formulas, so when we derive an equation for CPU time. Okay, for time being, clock rate and CPI and CPU time and turnaround time all affects the performance of the system at, that is performance of the system. Okay, and if you see here, so if you come to the system attributes which are affecting the performance are, so main is machine capability and program behavior. Okay, so these are the two important things that are affecting the performance. And machine capability can be enhanced with better hardware technology. Instead of 4 GB, we can buy 8 GB or 12 GB or 16 GB. We can upgrade the hardware, we can upgrade the uh, hard disk. So by increasing or adding the hardware, system can be enhanced. And similarly, innovative architectural features that also uh, uh, increases the machine capability. And efficient resource management. Okay, so that is also very important for machine capability. However, program behavior is difficult to predict due to its heavy dependence on the application and runtime conditions. Okay, so already we have discussed about that, the program behavior, and which are the things which are affecting the that's the program behavior, that is algorithm design, data structures, language efficiency, programmer skill, compiler technology. I think you are all in 7th sem, and you know all these things. You know, have learned algorithms, you have learned data structures, you have learned languages also, and programmer skill and compiler technology. Now, if you think, you know, all the things you have learned only for 3 to 4 months, uh, and still you are at a beginner level, because still it need times to become an perfectionist. Once you join the industries, then once you could start coding in real time projects, then these factors will affect the, so they will hire, or they want the computer science engineers who are good in algorithm design, data structures, and language efficiency. Okay, so language, if you are perfect in that language, and if you know how to use the data structures and algorithm design, so these two factors are very important for any computer science engineer to be successful in his career. Okay, so again, one more is, so we are measuring the performance by turnaround time. And in turnaround time is nothing but, which include disk and memory accesses, input and output activities, compilation time, OS overhead, and CPU time. Okay, these all things are involved in the turnaround time. And also we are measuring the performance of the system by clock rate and clocks per instruction. When we solve some problems, then you will understand how actually these different attributes will affect the performance. If you increase the clock rate, if you increase the clocks per instruction, or if you, well, how it will decrease the CPU time, all we will learn with the help of examples. And even you are going to solve those problems, I'm going to give that as a homework for all of you. So I will explain one problem you have to solve, the different kinds of problem based on that theory. Okay, okay.